Question 29, we've got our standard box on a slope, and we've got to put in all the forces and all the angles and everything on it. So it's got a weight of 20 newtons. So I've got 20 newtons pushing down here, but we always have to split this up into its components. And so this angle here is 30 from the 30 there. And so here I've got 20 cos 30 next to the angle and 20 sine 30 away from the angle. Got to do that every time. Can't sort of start worrying about those. We've got a normal reaction here off the page as well, R, which are actually telling us is 32. That's unusual. So 32 newtons is the normal reaction. And we've got a force here, P. And that P force is horizontal. So again, we're going to have to split this up. And so we've got the force going like this here, coming down here, 30 degrees again, like the Z angle there. So I've got P sine 30 over here, and I've got P cos 30. Getting a bit of a mess now, sorry. P cos 30 for that bit there. That's why some people don't write these on the diagram, because they get in a mess. It's rough as well, so we're going to have some friction stopping it moving up, and I'm putting it there because I really can't put another force here. It would all get in a mess. But you notice my arrow's pointing downwards because we are pushing it up the slope. Let's have a look at that. I just paused there quickly just to check I have my friction round the right way, because it does say in the question it's on the point of slipping up the slope. So yes, I do have my friction in the right direction. Right, well the job now is just to look at the forces in each direction. First of all, I'm going to do the forces away from the plane. So I've got this normal reaction here, this 32 that they'd given us earlier. And going in the opposite direction here, I've got the 20 cos 30. And I've also got this P force here coming down, and that's downwards as well. So that's P sine 30. And that's going to equal 0. And so if I want to get P all on its own, and I'm not going to tap in the coses just yet. I mean, I prefer to leave them here as long as I can. So we'll add that to both sides, and then we'll divide both sides by the sine of 30. And so there's what P is. We can tap that into the calculator. There you go, I've just tapped that into the calculator. It's given me as a root to begin with, but there we go. We've got 29. We'll round that to 29.4 newtons, can't we? So that's part A done, finding the value of P. And now to find the value of mu, we're now going to be looking at the forces in the other direction. So let's see what forces are taking it up the slope. So we've got this value here, this P cos 30 is pushing it up the slope. We know what P is now. What's stopping it is the 20 sine 30. And what's also stopping it is the friction. And it's on the point of slipping, so it still equals 0. It's not moving yet. We'll put an equals 0 in there. And so if I add the friction to both sides, the friction's just going to be this put into the calculator. Now I've tapped that in. I've used the answer, so I've not put 29.4 in. I've actually used the full answer there. And so that's giving me 15.42 as the friction. 15.425 or 15.4 really, isn't it? And what does mu equal? Well, friction equals mu R. The friction is the 15.4. The R is the 32. So if I just divide both sides by 32, then I'm getting 0.482 as my answer.